For this project of partial 1, we're gonna try to explain some different functions, and we're also gonna make an exercise. We're gonna graph it, solve it, we're gonna find the domain, the range, the intersections, and we're gonna apply all of the different methods that we saw in class.
A radical function can be defined as the quotient in which the denominator has at least one variable. To explain it in other words, the denominator of our fraction has to have at least one number or letter. We can have different types of functions, of radical functions, which are these four. They can be used in our daily life, and they are used to define distance, speed, and time problems.
Now I'm going to explain the slanted and oblique asymptote. First, to obtain the slanted and oblique asymptote, you first have to see if the denominator is bigger than the numerator. If it's bigger, you won't have an horizontal line. You will have an oblique and slanted asymptote. In this case, you need to resolve it by long division.
A piecewise function is a function in which more than one formula is used to define the output. Each formula has its own domain, and the domain of the function is the union of all the functions. And here is the basic form.
An absolute value function is an algebraic expression within an algebraic symbol. To graph the function, you have to substitute the x and put its pair.
Now I'm going to explain the applications in life for the piecewise function. They can be used in encounter situations. For example, in a business in which an item is uncounted once the other number exceeds a value. Another example is for the tax brackets.
This is our problem, that is Rx is equal to x elevated to the second power plus 5x plus 4, and everything divided into x minus 3. The first step is that we need to factorize to see if we are going on or we are not going to have a gap. So we factorize, and it's equal to, well, this. And we see that as you cannot cancel anything because they're not like the same, so there's no gap.
To get the intersections in both axes, we need to substitute 0. In the x case, to get the x-axis, it will be to substitute the y for 0, and then we get these values, minus 1 and minus 4. And then to substitute to get the y-axis, we need to put a 0 in the x, and then we get minus 4 divided by 3, and it is here.
To have the result of the oblique asymptote, that is this line, you have to do a synthetic division, that is denominator between denominator, that in this case is x to the second power plus x plus 5x plus 4 between x minus 3. And as a result, you get x plus 8 plus 28 between x minus 3. And you have to take only the linear function, that in this case is x plus 8, and it is represented in this line.
The domain is x belongs to minus infinite to 3 without including, and the union to 3 and to infinite.
The range of the function is minus infinite to 8 without including it, and then union with 8 without including it to plus infinite.
Now, in order to obtain the behavior, you first have to locate the asymptote. In this case, the asymptote is number 3. So, if we see number 3 from the right side, we notice that it goes up to the plus infinite. Now, if we see the 3 from the left side, we notice that the curve will go to minus infinite. Now, to obtain the final behavior, we have to locate the horizontal asymptote. In this case, we don't have an horizontal asymptote, so we have to just watch. And if you go from infinite, you notice that it will go close to the 8. And from the other part, it's the same. You have to locate the minus infinite, and it goes also close to the vertical asymptote.
From this, we can conclude that every single type of function has its way to use it, and that we can actually use them in real life. It's not something that you're not going to use at all, but you are going to use. For this project of partial 1, we're going to try to explain some different functions, and we're also going to make an exercise. We're going to graph it, solve it, we're going to find the domain, the range, the intersections, and we're going to apply all of the different methods that we saw in class.